Hello students, this is the sixth lecture on matrix algebra, and in this video lecture I'll be discussing system of linear equations. So before starting this topic, we should be familiar with few terms like what is a linear equation, what is a solution. So let us begin with what is a linear equation. So the equation which is of the form a1x1 plus a2x2 and so on to anxn, which is equal to b. So the equation which expresses the real or complex quantity b in terms of the unknowns which are x1, x2 and so on to xn, along with the coefficients which may be real or complex which are a1, a2 and so on to an. So any equation which is of this form is said to be a linear equation. Now what is a solution? So a solution to the linear equation 1. So I have marked this equation as 1. So the solution to this linear equation 1 is the sequence of numbers s1, s2 so on to sn which have the property that the equation 1 is satisfied. Whenever I put x1 equals to s1, I replace x2 with s2 and so on if I replace xn with sn, and this equation is satisfied. So that is called the solution. So let us discuss this through an example. If we have a linear equation 6x1 minus 3x2 plus 4x3 equals to minus 13, and if I claim that x1 equals to 2, x2 equals to 3 and x3 equals to minus 4 is a solution of the above. So it means on satisfying x1 equals to 2 and x2 equals to 3 and similarly x3 equals to minus 4, we'll be getting minus 13, and that is what I have proved here. Now in general, a system of m linear equations in n unknowns x1, x2 so on to xn, or a linear system is a set of m linear equations each in n unknowns. That is, if we have a system like a11 x1 plus a12 x2 and so on to a1n xn equals to b1, a21 x1 plus a22 x2 and so on to a2n xn equals to b2 and so on, am1 x1 plus am2 x2 and so on to amn xn equals to bn. So this is said to be a system of m linear equations in n unknowns. Now let us discuss if we have this system and what are the categories of solution in this. So I have broadly classified the solution in two categories. One is consistent and the another is inconsistent. So if this system has a solution, then it will be called consistent, and if this system of linear equation has no solution, then we call it as a inconsistent. Now few important remarks. The first is if bi's are 0. So if I say that this is our system of linear equation and if all the bi's are 0, it means b1 is 0, b2 is 0 and so on to bn is 0. Such kind of system is known as homogeneous. And if bi's are non-zero, we call it as inhomogeneous or non-homogeneous. One thing which we can clearly observe from here is if all the bi's are 0, so x equals to 0 will always be the solution of this. So that is what I have written here. For homogeneous system, x1 equals to x2 equals to so on to xn equals to 0 is always a solution, and this solution is known as a trivial solution. So what is a non-trivial solution? A solution to the homogeneous system in which not all xi's are zeros. That is said to be a non-trivial solution. Further, we will be discussing various methods to solve this system of linear equations. The first method which I have discussed in this video lecture is elimination method. And let us understand this elimination method through an example. So the first example which I have considered here is x plus 2y equals to 8, 3x minus 4y equals to 4. So if I multiply the first equation by 3 and then subtract it from 2, that is if I multiply the first equation by 3, it becomes 3x plus 6y equals to 24. And now if you subtract this from the second equation, that is 3x minus 4y equals to 4. So on subtraction you will be getting 10y equals to 20, so which implies y equals to 2. Now substitute y in either of the above equation to get the value of x, and you will be getting the value of x to be 4. So it means x equals to 4 and y equals to 2. It is the unique solution of the above system of linear equation. Furthermore, now consider the system of linear equation x minus 3y equals to minus 7 and 2x minus 6y equals to 7. Now if I use the same approach which I have used in the first example and I multiply the first equation by 2 and subtract it from the second, so what you will be getting is 2x minus 6y equals to minus 14. And our second equation is 2x minus 6y equals to 7. Now if you subtract these equations, so this will get cancelled out. Here we are left with 0 and here we are left with minus 21. So 0 equals to 21, 0 equals to minus 21. So this is something absurd, so which makes no sense. So it means this system is inconsistent. That is, no solution exists for this system of linear equations. Now in the third example, I have considered x plus 2y minus 3z equals to minus 4 and 2x plus y minus 3z equals to 4. So if I multiply my first equation with 2 and subtract it from the second equation, we will be getting this equation, that is minus 3y plus 3z equals to 12, or if you divide the whole equation by 3, you'll be getting y equals to z minus 4, where z can be any real number now. Now if you substitute the value of y in either of the two equations, you will be getting the value of x, and x comes out to be z plus 4. So the solution above is x equals to z plus 4, y equals to z minus 4, and z can be any real value. So if you vary the value of z, you will be getting various values of x and y. So this linear system has infinitely many solutions. So I have discussed three examples here. In the first example, we have observed that the solution was unique. In the second case, we observed that the solution was inconsistent, that is, no solution exists. And in the third, we have seen that there were infinitely many solutions corresponding to the system of linear equation. So a very interesting question which arises from here is, why don't we discuss the case of finitely many solutions? Why are only three categories of solution: infinitely many solution, no solution, or unique solution? So why don't we discuss the case of finitely many solutions? And the second most important question which arises here is, what is the graphical interpretation of the above discussed cases? So for the answers to both of these questions, you can go into the description box and I have mentioned the link of my previous video lectures. I hope you have understood this video lecture. Thanks for watching.